test. Good. Hi, everybody. I'm Dan Russell. I'm the author of this book, The Joy of Search. Now, it's a book about Google, and you might think you know how to use Google. And the point of my talk today is to prove to you that there's more to know and that you really should pay attention. So let me give you a little bit of background here. I work at Google. I've worked there for 15 years. And my job there is to be a senior research scientist studying how people search. So you may think you're an expert searcher, but one of the really interesting things I found is that everybody thinks they're an expert searcher, and only 50% of us are above the median, right? This is true. So here's a prediction. Some of us are not. So I've studied this for a long time, and I do a lot of teaching. And in the process of teaching, I've discovered that some fundamental things that people you think would know, they actually don't. And that's what led really to the development of this book. So The Joy of Search is really a question about how do we think? What's the mental model that you have of Google? Is it just an infinite answer engine? Is it just a bunch of full text queries? How does it really work? Do you know? Now, I started writing this book actually as a blog many years ago. And then, as like I said, I did a lot of teaching of classes. I go out to fourth grader classrooms. I go to NASA. I go to the Library of Congress, and I teach people how to search. And guess what? Fourth graders, NASA rocket scientists, they're kind of the same. Okay, that's the deep secret here. Because a lot of people think that Google is just a way to get answers to life, the universe, and everything. And of course, if you type that into Google, you get the right answer, which is 42, right? You knew that. Here's a question for you. How did that work? It's clearly not a full text search, right? Oh, you might say, oh, Dan, that's just an Easter egg. Yeah, there's more. What about something like this? What is the airspeed of an unladen swallow? Remember this? Yes, you're old enough to remember that. Answer is 31 to 40 miles an hour, and it's not an Easter egg. That's the actual speed as we've determined by doing some fancy text analysis. So what's your mental model of Google? How does it work? How about this? What color is the sky? We say a cloudless sky in the daytime appears blue. Question for NASA rocket scientists, what's the color of the sky on Mars? Question for you, how does Google know this? How do we figure it out? So the book is basically, it's not really written for scientists. It's really written for everybody. It's written for that fourth grader. It's written for my mom. It's written for everybody. So each of the chapters in the book is really a story. And some of the stories are like this. If you go to Google Photos, you know, your Googleized collection of your pictures, and here I've done the query fish, and you get a lot of fish pictures, which is not surprising, except I didn't tag them as fish. How does it know? Better yet, see this one up here? That's a can of beer. It's Whale Shark brand beer. What it did is it recognized the silhouette of the whale shark right there. Or this one. This is actually a freezer case full of frozen fish. It doesn't look like fish. It looks like chunks of ice cubes. But Google Photos read the caption on the sign of the container. So there's a lot more going on here. Look, we built a computer the size of a planet, basically. And we're doing all kinds of additional processing you might not know about. So I wrote a bunch. So you can now, for example, ask questions of Google like this. When did the Giants last win the World Series? And we will tell you the answer. Not by doing text analysis, but by doing some fancy natural language processing. So you might have heard me or somebody a few years ago say, choose a few keywords and type them in, and you'll get the answer. We've moved beyond that. Yeah, you can still do that. That won't be bad. But additionally and increasingly, you can ask fully formed natural language questions like this one. Or perhaps my favorite one, how old is Donald Trump's wife? What do you think the answer is? Well, there are 3 answers, okay? Depending on which wife you're referring to. And the thing to keep in mind here, the reason I find this interesting is Google doesn't know the normal human protocol is, oh, you mean the last wife. Right? No, Google understands there are 3 possible answers, so it gives you a list. So the way Google thinks is different. You can buy an app, for example, that will identify mushrooms. This is not a Google product, right? But you can get an app for that that will identify mushrooms. It has a 5-star review. Only survivors give reviews, right? So the important point for you as a literate user of search or of apps that do search is to understand the basis on which that information is getting accessed and being presented to you. Bottom line, don't trust any mushroom app. Get the training. So how does Google work? If you type in an arithmetic expression like this, sine x squared plus cosine y, we give you this beautiful 3D model animated. I wish I had this when I was in high school, but you know. Point is, we now have lots and lots of information, and a lot of people I interview in my studies say, oh, Google, you're like this. You have every book, every edition, every magazine, 24/7. This is not true, right? But people will say that. And so when I ask people in information schools to draw me a model of how Google works, they will draw pictures like this. It's got a search engine and it indexes content on the web and have web crawlers. It's fabulous. Here's the gotcha, though. Less than 10% of the pictures drawn by over 1,000 computer science and iSchool students in the US look like that. Most of them look like this. I asked them, draw me a picture of how Google works. And what this person wrote was several overlapping concentric circles of nonlinear Boolean targets. I have no idea what that means. I don't think that person knows. What's so fascinating to me about this is that when you look at all these pictures of portraits of Google mechanism, 1/3 of them have the word magic on them. 1/3 of them, basically, the people say, I have no clue. It's pure magic to me. It's like saying my gasoline engine works because of demons, right? You have no concept. So I wrote this book. And each chapter is basically a story. And the stories are all motivated by little research questions. So you know, as a scientist, you have this research question. And as a person, we have all these research questions which stem from curiosity. Or in this case, a friend of mine sent me this picture and says, Dan, I know you can figure out where this is in the world, right? That's not the question. The question is, where was I standing when I took the photograph? And what's the phone number of the room where I'm standing? Okay? That sounds like an easy thing to do, right? Of course, right? No, it sounds crazy hard. So what I did to solve this question is I worked with what I had. And if you look at the very top of that building, it says ampersand TP. So it's the corporate logo, right, on the office building. So it turns out if you go to Google and search for TP office buildings, you do not, in fact, get toilet paper office buildings. But you get office buildings that look like this. And there it is, the TP office building in Warsaw. Who knew? Well, it doesn't take long to figure out that that office building is at 1416 Varda Street, downtown Warsaw. That wasn't the question. The question is, where was the person standing when they took the photograph? But once you know that, you take the original photograph and, if you know how, you can launch Google Earth. And Google Earth has this capability to do 3D building models, right? Did you know that? How many people knew that? Okay? The rest of you pay attention, okay? Because what you can do is turn on 3D building models, fly to Warsaw, fly to Varda Street, and then align the view along with the image. So this is the photograph, and this is the 3D model from Google Earth. Aha! Now what? Remember, you're trying to figure out where the person was that took the photograph. So you turn around, exactly right. Who taught you that? Right. Nobody teaches this to you in computer science or library school or in the library. Nobody tells you, well, what you do, turn around, and you figure out it's Emily Plotter, 53. That's cool. Now what? Well, I have a solution. So what you do is you go back. Remember, one of the principles here is to use what you've got. And if you look closely at the original image, there's this kind of blurry blue thing here. And it looks like a reflection, so I'm going to reflect it back to see what it is. Can you read that? It's the Google logo. It's better on my monitor than up there. It's the Google logo. Oh, I know what street it is. I know it's the Google office. So if I do a search like Google Offices Warsaw, there it is. That's the street address. That's the phone number. And it's trivial to figure out what office. Are you amazed? I was pretty amazed I was able to figure that out. The point, there's a lot to learn here. Not all search sessions are fast. This took me about 10 minutes. Most people get their Google searches done in like 30 seconds. Most of our students, including grad students, think that they can get it done in 30 seconds, or an extremely good graduate student might be 45 seconds. See my point? Sometimes it takes minutes. It also helps if you can link all of these resources together and you know what's possible. So, there are 18 chapters here, each of which is a story like this. Let me tell you one more story, and then I'll tell you an interesting research result. Here's a story. I was in Bonaire a few years ago, and if you go to Bonaire, beautiful Caribbean island, beautiful white sand beaches. Where does the white sand come from? Do you know? Yeah, these guys. And the question for me was, what happens is that these are photographs I took. The parrotfish approaches the coral, takes a bite, and then moments later does that. So those nice white sandy beaches you're sleeping on, it's parrotfish poop, basically. And the real question as a scientist would be, how can I quantify that? How much poop would a parrotfish poop? Never mind. You get the point, right? So let's do a Google query on this. I know that's a stoplight parrotfish, and so I just want to do the obvious search. The obvious search takes me to a couple of results. And the interesting thing is if you do a little bit of looking around, you get two answers. It's either 90 kilograms per parrotfish per year or 900 kilograms per parrotfish per year. Somebody's wrong, right? That's an order of magnitude difference. So let's do a little bit of research here. So, for example, if you look at this one, here's yet another result. Beautiful paper written in marine biology. It says it's 360 kilograms per year per parrotfish. Okay, let's figure it out. So let's do the obvious thing. And so I looked up a bunch of different results, and the most common result is it's 200 kilograms per parrotfish per year. Okay. In particular, this is a really nice result from Wikipedia. Okay. So I think this is cool. This is a book, Marine Biology, Chapter 12. I click on it, and it's dead. You have to figure out how to live in a world where roughly 40% of the links you care about go bad every year, right? This is a huge problem for us, for you, for our graduate students, for our faculty, and so on. So how do we be resilient? So in this case, it turns out it's really hard to get that book online. It's still in copyright. So I ordered it from the library. Imagine that. I actually got the physical book, and I turned to page 310, and it says, blah, 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 parrotfish, 90 kilograms of sand per year. Cool. Are we done? Well, let's think about this carefully, because another really common resource, the Florida Museum of Ichthyology, has this result. Parrotfish may produce 1 ton of coral sand per acre. Okay, we're getting really different results here. The key point here, for you to be a good power searcher, you need to be resilient in the face of discrepant data and data that just disappears on you. So let's take that quote from that book and actually do a double-quoted search for this phrase. And you'll find, here's the reference. Great, I think I'm done. I go and look up this reference. Oh, that reference doesn't exist. Somebody miscopied the author's name. That's not a real name. You see where I'm going with this? We need to be really powerful in our ability to search. That's the actual reference. Somebody somehow managed to turn that into that. And when you go there, you can very easily look it up and find the citation, find the paper, and so on. And it turns out that the key result here is it's 2,300 kilograms per hectare, and I wanted to convert this into kilograms per acre so I could actually compare it with other results. Key insight for you. Did you know you can do conversions like this? This is immensely handy because in the United States, we live in a brain-dead world where we use English measurements and imperial measurements. No, I do not know how many tablespoons of water are in a kilogram. I just have no idea, right? But doing these conversions is amazingly handy. And so in this chapter, I show you how to do this. And notice the conversion here, kilograms per hectare in kilograms per acre. So we get it down to 930 kilograms per acre, et cetera, et cetera. Another key point, don't trust one result. Do not trust one result. I mean, we already saw that they vary by order of magnitude. So the book chapter goes through enormous detail about how to go this. And I hope it's entertaining, because as a marine biologist and a sort of nascent ichthyologist, I'm really interested in this. So the bottom line is, it turns out you need to figure out how many parrotfish there are per acre. Turns out there are about 10. They each produce about 90 kilograms, and that accords with the very first result we found. And the other one that's off by factor 10, it's a typo. You knew this, right? But it's in the published literature. And that explains a lot of the variance, because people have then continued to copy and refer to that bogus paper. So that doesn't surprise you, right? You know link rot happens. You know scholars sometimes get their citations wrong, and they get the numbers wrong. So Google Scholar is a great handy resource to find peer-reviewed articles. How many people use Google Scholar? Okay, the rest of you need to figure this out. Type in Google Scholar into Google and you figure it out. And cross-check resources with each other. There are other chapters in the book where we talk about, for example, when was oil first discovered in California? Links with the previous speaker here. When was oil first discovered? Turns out it's not that easy to figure out. You have to do the scientific thing and define your terms and so on. So I'm going to skip this chapter. This is probably the most fun chapter ever, but I'm going to skip it and go to something at the end here, because I want to tell you this interesting result. So it turns out that you all probably have this basic skill of finding text on a web page or in a PDF or a PowerPoint or whatever, right? How would you do it? What would you do? Control F. Yeah, fine. Yeah, same thing. So we all know this. Okay. So I was interviewing a young woman less than a mile from Apple corporate headquarters, and she's spending forever looking for a name in a long web document. I thought, what is she doing? What is going on? So finally, I discovered she didn't know how to do this, right? So this is the Macintosh version of Control F, right? Command F or Control F, right? She didn't know it. So I did a study. This is not in the book, but I figured you'd be interested. And I asked a bunch of people, here's the results of a local 5K. How long did Beth Smith take to run this race? It would take you what, 10 seconds? Take all of us about that time, 12 seconds max, right? So I did this study, and look what the results are. We are over here in the 10-second bucket, but there are people out here at 300 seconds. Trust me, I did the study. There are people at 600, right? What's going on? Answer, they don't know Control F. And I thought, wow, well, how is this even possible? So the thing that just blows my mind about this result is that when you get beyond 120 seconds, beyond 2 minutes, 25% of the answers are wrong. This is a trivial question. So what happens is that people who don't know Control F don't know copy paste. They can't copy the number from the web page into my form. So they try to remember the numbers and they switch to, or they forget, they think it's a 7 and it's actually a 5, whatever. How is this possible? So I did a survey of 2,200 English internet users, and 90% do not know this. Astounding, right? When I did Firefox only, it turns out to be 93%. So, I have run this study so many ways. I'm now, I think, up to around 10,000 people, so I probably sampled you. Yeah, it's actually, you know, the big thing about it was I went home and I told my wife this thing, and I said, you know, I've met people in my study who don't know Control F. And she said, what's Control F? And I thought, oh man, have I got a result. So to sort of deal with this, I started building a couple years ago this online class called ParaSearchingWithGoogle.com, which tries to teach people to do this, because it was such a problem. It was just killing me. People don't know this. So Control F is like lesson 1 in this. We also found that if people who know Control F are 12% faster in their searching, 12% is a lot, right? So go ask your wife, your husband, your boyfriend, your girlfriend, your dog, do you know Control F? And if they say no, please teach them. You'll make them faster and much more efficient and much more accurate. So my class does this, and I want to wind this up by saying, you know, this book is really trying to teach the rest of the world, the people who don't get into my MOOC, my online class, how to remember and how to use these skills. It's a set of stories, not highly technical. I hope they're fun. I hope they're engaging. They're stories you can tell, because that's sort of the cognitive nugget I want people to use and remember. And so, it's my book. I'm going to be over at MIT Press booth if you can answer questions or sign your book or something. But it's the kind of thing, this is not sort of optional anymore. Search is fundamental. I will argue more that research is a fundamental skill that should be taught in every school. I hope some of you will help me do this, because there's online research, there's lab research, there's bench research, but this is a fundamental skill all of our students need to do. Thank you very much. And I've got a couple questions, a couple minutes for questions. So if you have a question, let's hear it. Yes, sir. Yes. Yeah. No, yeah. The question is, was I assuming all the white sand is produced by the parrotfish? No, I'm not assuming that. All right. But it's a big chunk of the sand. It's a very big chunk. Actually, it's a great question. Part of what I do talk about in the book is how do you formulate a good research question? And part of it is being careful about what it is you're assuming. Question your assumptions. So, do I assume 100% of the sand is made by parrotfish? That's a great research question. What fraction is? Right. So that's a good point, though. Question over here? Yes. Okay, let's go with you. Then you. That's a great question. The question was, how many of the techniques in here would apply to other search engines? All of them. I specifically didn't do anything that was specifically Google. And in the book, I actually give examples using Wolfram Alpha and Bing. And I think there's one example using Yandex. Because Yandex, these are all different search engines, right? And so in particular, if you're in, say, Korea, you want to use Naver, right? So the idea was to make them as general as possible, so the book wouldn't go out of date in like 6 months. Did you have a question? Right. 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 Mm. Right. 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 Yeah. So the question is, are we just giving up on half the population because not everybody's going to take Dan's class or read Dan's book or be online, right? So I hope the answer is no, because you're absolutely right. The way most people learn a lot of this stuff is by friends. How did you do that? Show me how you did that. How did you do that search? So that sort of social peer connectivity, that lesson, that informal learning is deeply important. But that's how we get to the other 50%, is by teaching half of the world how to do these things, and then I'll see it over your shoulder and say, oh, how do I do that? Okay, I think I have time for 2 more. Yes? Yeah. Okay. The question is, how many people in the Control F study did not use keyboards? 0. This is all people who did these surveys online, or actually built a bunch of tests. Yeah. 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 No, I controlled for that too. I, I, I was so blown away by this. I ran this study many, many, many times. I changed the wording on the surveys. I included Emacs commands. I did absolutely everything I could think of. It never moved. Never moved. Okay, last question.
And let's say it's on a topic like fossil fuel divestment.
Yeah.
How the same stuff keeps coming up over
Right.
and over.
So it's a really great question. If you're doing a topical search and the same results keep coming up again and again and again repeatedly, in the book I also talk about a way to get rid of those using the minus command. So you, for example, suppose they're all coming from the energydepartment.gov, and you want to just get rid of those. Say minus DOE.gov, and then it will remove all those results. So in general, that's a way to get rid of stuff that you keep seeing repeatedly. Okay, I think I'm out of time, but thank you so much for coming and staying. Appreciate it.